So now we are starting with the curve of standard functions. In that, first standard function is the curve of constant function, or we'll say function is given constant function. We should find out what type of graph it is going to give. And constant function, whenever you write, you will be writing that function y is equal to fx is some constant. Constant c can be 1, can be 2, can be 5, can be 10, can be 2/3, no problem. So y is equal to fx is equal to c is your function. And if I say you plot this graph, when you plot this graph, when you put x as 0, answer come out to be c. F1 when you put, your answer is c. F2 your answer is c. F3 your answer is c. F4 your answer is c. So that means anywhere if it is C point, at 0 your answer is C, at 1 your answer is C, at 2 your answer is C, at 3 your answer is C, at 4 your answer is C, at 5 your answer is C. That means the graph come out to be like this, which is a straight line parallel to x-axis. And this curve will be simply be called as y is equal to C, or we should say fx is equal to c. It is clearly a function. You draw any vertical line, you will find that it will cut the curve only at one point. So we will say yes, it will be a constant functions curve. Now, few more things I want to tell here. First, we should find out what is the domain of this function. Domain means what value of x I can place. I will say whatever x you want, I can place it. 0, -1, -2, -5, -100, -200. Anything you put it, you will get answer always come out to be C. So domain of the function will be all the real. What should be the codomain? Codomain always we are going to have as a real number. So here in this case, when you draw a mapping of this function, domain will be all the real number. Here codomain will be all the real number. Here we have C. Here what you will find that any value you take of real number, their image come out to be C only. So we will say this will be the function we will be having. So here in this case, when we have a constant function, we will say this will be the domain. Domain will be all the real number. Codomain will be all the real number. But what about the range? Range is only C. So when I say domain is R, codomain is simply R. And what about range this time? Range will be only C, one element. So domain is known, codomain is known, range is C. So this will be the standard function. We have first one. And one more thing note here. When you plot this graph, you can plot this graph without lifting your pen or pencil. This line I can draw can go to infinite. This way I am not going to lift my pen or pencil. We will say yes, this curve will be continuous. Or we should say continuous function. This function will be a continuous function. Continuous means continuous everywhere. Continuous function everywhere. So this is the first function we have, which will be a function having domain all the real number, codomain all the real number, range will be C, and this will be a function which will be continuous everywhere. One more thing I'll add here. Whenever we think about differentiability, that I'll tell you later, but in the graph, I'll tell you where the function is differentiable, where the function is not differentiable. Differentiability meaning I'm going to take as a separate chapter, but here because we are plotting the graph, we should know what is the differentiability and how we check on the graph that function is differentiable at every point or not. If any curve you are going to have, if that will not have any corner point, that means this function will be differentiable everywhere. Function if continuous, then we can think of differentiability. And if the function is continuous, it is without break it should come. And when I say the function is continuous, then we think about differentiability. And what that differentiability says that function is differentiable only when it does not have any corner point. For example, if the graph goes like this, no corner visible here, we will say yes, this function is continuous, it will be differentiable. This curve if I take, then what you will find, in this case, this is one corner point, this is another corner point, this is another corner point. This function is not be differentiable here, this will not be differentiable here, this will not be differentiable. So if you want the function to be differentiable, it should be a smooth curve or should be a straight line. If there is some corner point, we will say function is not differentiable. So what you say about this function? This function was continuous and at the same time, it will be differentiable everywhere. Differentiability definition done in 11th class. One more time I'll do, but this is the basic I told you in the graph. If the curve has corner point, we'll say differentiability fails. But here in this first curve, we will have function is continuous as well as differentiable. I told you what is domain, what is codomain, what is the range of this function. Now coming on second curve, that is identity function. Second function is identity function.
सुनो 9 PM लिख दिया आपने, वो एम होगा ना?
आप कर दो ना उसको, चेंज करनी पड़ेगी. Now identity function. Identity function is a function where fy is equal to fx come out to be simply x. Now when we have the function y is equal to fx is equal to x, then in that case, if I plot it, y is equal to x. In this case, x when you put 1, y is also 1, x you take 2, y is coming 2, x is coming 3, y is coming 3, x 4, y is coming 4. X 0, it's 0. X minus 1, y is minus 1. So when you plot this, it will be 0 here, 1 it is 1, 2 it is 2, then it is 3, then it is 3. So here we will say the line come out to be like this. Minus 1, minus 1, minus 2, minus 2. So this type of curve we will be having in the second case. This is your fx, y, and this will be your x. So identity function comes out to be like this. So in this case, what you will find, this type of curve I am going to get, and if this curve be right, it will be y is equal to x. If you remember, in the straight line you have done y is equal to x is the curve or the straight line which is making angle 45 degree, this side 45 degree. This will be a function's curve because if you draw the vertical lines, it will be going to cut the curve only at one point. Now my question comes, what is the domain of this function? Is there any value which you can't give to this function? I will say any x I can write except the infinity. Infinity is not a real number. So I'll say the domain will be all the real number. Codomain will be also a real number. Codomain of function is always real number. Now what will be the range we should find out? Now when you think about this, this is a real number, this is a real number. If you take 1, 2, 3, 4, so on. Here it is 1, 2, 3, 4, so on. 1 will have image 1, 2 will have image 2, 3, 4, 5, this way. So what you will say, range will be this complete real number now, because whatever elements here, they will have their identity as the image. So we will say range. Range will be again all the real. So domain of the function is all the real number, codomain is all the real number, range will be also real number. Is this function continuous? Without any break, I can plot this curve. Without break, I can plot this curve. So this will be called as continuous function everywhere. So this function is again continuous. everywhere. Now, is there any corner point visible to you? We'll say no. No corner point, is a straight line coming. So we will say yes, it is differentiable everywhere. It will be continuous everywhere, it will be differentiable everywhere. So the function is continuous as well as differentiable everywhere. And the shape of the curve will be simply y is equal to x. This is a line passing through origin making an angle 45 degree with x-axis. So this will be the curve number 2 called as identity function. Now coming on third function, that is modulus function. So that we'll do in next class. Two functions I have completed because this will not be explained in this video. So we'll go next.